Hi everyone, this is Dr. Gwen Schlichter. This is a mini lecture as part of a series of mini lectures on the marine environment, chemical and physical features of the ocean. Today I'll talk a little bit about geography and environmental conditions in the ocean, and I'll touch on ocean movement. So if you were to guess, what would you say is the amount of the northern hemisphere that's covered by water? What about the southern hemisphere? What you should know is that the ocean dominates, which I'm pretty much sure you can see if you look over here on the map. There's pretty much ocean everywhere. 61% of the total area of the northern hemisphere and 80% of the southern hemisphere is actually covered by ocean, about 70% total. Now these numbers are a little bit different from place to place that you look, but basically a lot. Really what we see on the map when we look at a map here, we see just the blue, but really what you're looking at is a pretty amazing sea floor that's just as complex as the continents that you see in terms of mountains and oceans and canyons like the Grand Canyon. You can see some of them you might be familiar with. Mariana's Trench here is one of the most famous ones that a lot of people have learned about or seen like a documentary on. But as you can see here, there are a lot of complexities that are on the ocean floor that we're not even aware of, because of course we only see the surface of the ocean. What's important to also remember is that the continents weren't always where they are today. And you may have seen a map something like this called Pangaea. But essentially in 1912, Alfred Wegener proposed that at some point in time there was a place called Pangaea, or rather the Earth was Pangaea, in terms of the fact that all those continents kind of fit together like puzzle pieces. And when he looked at the structures, it just sort of made sense by the way that the contours and continental shelves, which we'll talk about in a minute, of each of the different locations or continents. And so he proposed that about 180 million years ago, it looked something like this. Of course, people laughed at him, right? They were like, you're crazy. But if this hypothesis is correct, what evidence do you think we would need to support it? And so that's the kind of evidence people looked for in this concept of continental drift, which is the continents drifting apart over time. So some of the evidence they looked at was these puzzle piece effect, right? You can see it here on the picture, but also rock layers that are matched. So when these things came together, like right here between South America and Africa, were the rocks or the type of rock that formed the edges here, were they similar? And they also looked for fossil similarities of organisms that might have existed, or other fossilized things like plants that might have existed at those locations. And what they did find was evidence of exactly that. Here's a picture of continental margins. This is something that's good to familiarize yourself in. When we talk about continental margins, we're talking about boundaries between continental crust and oceanic crust. And here you can see a little picture that sort of lays it out for you, a diagram of it. And it shows you the continental shelf, the shelf break, the continental slope, the continental rise, and the abyssal plain. And what it's important to know is what you kind of see at each of these locations. So here's the continental shelf. It's circled here at the top so you know what you're looking at. And what you want to know about the continental shelf is that it's essentially, I'll put my picture right here on top, it's 8% of the ocean surface area. The richest area of diversity is really here on the continental shelf. So this location right here that is circled contains really most of the biodiversity that we see on the planet in terms of the oceans. It's about, a kilometer, maybe up to 750 kilometers wide. And it ends at the shelf break. So it's about, for us, we would imagine it in feet, so 1,300 feet down, up to as much as 94,000 feet down. So that's the continental shelf. The continental slope, as you can see right here, is a bit farther down. It's very, very steep. So it's the edge of the continents, what we perceive as that. It's much steeper than the continental shelf and the continental rise. And it's what we term the shelf break to to the deep sea floor, so when you actually hit the deep sea. And then we have the Continental Rise, which forms by sediments that have been pushed down from the Continental Shelf and the Continental Slope. It's like a river delta, if you've ever seen a river delta, and this is usually formed by sediments of remains of organisms, shells, also sedimentary rock. And we'll talk about that in a minute. So here's some of these types of marine sediments here. We have lithogenous and we have biogenous. And it's not really that hard. Litho means rock. That's, if you've heard the term lithograph. That means rock, and you can see that it's made up of little tiny rocks. And then biogenous is biomatter, right? So shells and things that were once living organisms. And why do I even care about telling you about this? Well, because we can learn a whole lot from marine sediments, which is really cool. These, of course, are breakdowns of rocks, and these are the skeletons and shells of marine organisms. And it can tell us a lot about what the ocean must have looked like in the past. We can use the age of these sediments to figure out carbon dating and figure out exactly how old those organisms are and what it was like in the ocean at that time. It also gives us a lot of evidence of temperature. And when we make all these predictions about global climate change, we're using a lot of ancient information about how temperatures have changed in the past relative to how they're changing now. So we're using a lot of information based on data, or scientists, not me particularly, but scientists. I wanted you also to be familiar with the types of continental margins. So if you have like the South American plate here, you want to think of the fact that we are talking about different plates that are essentially like shifting over each other, right? And we have different kinds of plates. We have active margins that create, or plates that create active margins, and passive margins. These, you may hear them talk about this in the book a bit. And we have active margins here on the Pacific Ocean side and passive margins often on the Atlantic Ocean side. You want to know about active margins that they're more intense geological activity. So they're really the interesting ones, right? That's where we have earthquakes and volcanoes and trenches. And not interesting in terms of the fact that it causes a lot of damage to both people's homes and their lives. But the fact that it's really where like activity happens from a geological perspective. They're generally steep, rocky shorelines. We know that because that's what we have on the West Coast, right? And the West Coast shoreline is really rocky. If you go up and down the coast here, you'll see that. There's narrow continental shelves and steep continental slopes. Once again, something that you're probably familiar with if you've ever taken a coastal trip. So passive margins are very different. They tend to be flat and wide coastal plains. And if you've gone over to the East Coast and gone up and down that coast to look at beaches, for example, you would notice how different it is from the West Coast. There are wide continental shelves, gradually sloping continental slopes, and so we don't get this like really dramatic slopes and cliffs like you do here on the West Coast of the United States. It's also interesting to note that the Atlantic Ocean is continually growing and the Pacific Ocean is continually shrinking in terms of the fact that we're having these constant continental shifts. And so you're going to see, not over your lifetime, but we're talking about over geological time. And so remember that continents are constantly shifting, and which direction they're shifting affects how big that ocean is. That's just a brief outline of some of the things that they start to talk about in the first chapter of your book. I'm going to go into more detail in other mini lectures about other properties of the ocean and physical and chemical properties of the ocean. So stay tuned for other mini lectures. Thanks so much for watching.